First, let's look at how different operators react to being asked to work on a combination of integers and floats. Remember, an integer is any number without a decimal point, and a float or a floating point number is any number with a decimal point. So this code creates three variables, myint1, myint2, and myfloat, and then on line 6, it adds an integer to an integer. The result is an integer. 1 plus 2 is 3, and the data type for that 3 is an integer. Python knows that if we add two integers together, our result is guaranteed to be an integer. On line 8, though, we add an integer to a floating point number. We add 1 to 3.0. Now these are different data types, but it does make sense to ask what the sum of 1 and 3.0 is. The answer is still 4. Here, though, Python assumes that the answer should be a floating point number. It effectively converts the integer to a floating point number, 1 to 1.0, and then adds 1.0 to 3.0 to get 4.0. The reason for this is because Python can't guarantee that if you add an integer to a floating point number, that the result will be an integer. In fact, usually it won't be. If you added 1 to 3.5, your result would be 4.5, which is another floating point number or another decimal number. So Python intelligently figures out what kind of data type to use in the output based on what kind of data types are used in the input. This combination of integers and floating point numbers operates the same across all the mathematical operators. Anytime we combine an integer with a floating point number using any mathematical operator, our result will be a floating point number. This is generally pretty unsurprising, except for potentially when we use the floor division operator. Even when operating on floats, the floor division operator will still give us a floating point number, even though it's guaranteed to be a whole number. That's not too important to understand right now. It's just kind of an interesting observation about the way Python works. We might assume that dividing an integer by a floating point number using floor division would still return an integer, because floor division always rounds down to the nearest whole number. But in this case, it keeps the point 0 on that whole number.